Cool. So we're gonna be looking at the Maximum Product Subarray. This is basically an extension of the previous Maximum Subarray. In this case, we're finding the subarray with the maximum product. So it's a small little twist because we need to incorporate for negative numbers. Okay, cool. So I have the problem statement up here, and here is one of the sample inputs that was given in LeetCode. So nums1, the array is 2, 3, negative 2, 4. So let's just go over how we should go ahead and approach this. So we're going to do for each value in the array. And then what we need to do is for the regular subarray problem, what we did is we had a current max. Then we also had a real max. With this one, current max being maximum, or it was maximum sum with current subarray. This is a global max. So basically the current max we had before, we would iterate through the list and start adding values. And we would check if adding a value made the array bigger or lower. And then from there, what we would do is either we would add the current index to our subarray, or if not, let's say adding the value. If adding the value to the current subarray would make it somehow less than the actual current value itself. So let's say a little twist we need is we need to account for the negative number. So when looking at this problem, the easiest way I could facilitate in my head, a negative number will basically flip it'll flip this number. And the easy way to see this is to say the local max. We have it so far with 7. Let's say we hit 7. And then let's say the local min is, let's say it's 1. If we hit a negative number, what we're going to have to do is we're going to have to flip those. Flip the locals. And the reason for this is the negative number will turn our local max or our local min into be reversed. So 7 times negative 1 will give us negative 7, and then 1 times negative 1 equals negative 1. So if we keep them in their current positions, max will be negative 7, and then min will be negative 1, which doesn't work because negative 1 is bigger than negative 7, right? So we have to actually flip these values as we keep going through the list. This is really the only real change you're going to need. And then other than that, if you understand the previous video, pretty straightforward. Then you understand this one. If you haven't watched that one, still recommend it. Just so we go through how we actually approach this value, or how we actually approach this problem. Once again, don't really like getting an algorithm type LeetCode problem just because you need to kind of know it. And I feel it's one of those where if you forget to study it or you're doing some intro ones, this is one of those where you just either know it or you don't. But yeah, let's get into the actual solution here, and I'll just walk you through it. Okay, so here I have my main function. I just have the 2 sample arrays, and it has system.println max product of sample number 1. So this is just standard. And now the actual function we'll be working on. Yeah, the max product, the minimum product, and the result. So I guess the easier way to think about this is, let's rename these. Cool. So this is probably the easiest way to think about this, right? You have the local maximum relative to your current subarray, your minimum local, which is again the minimum value within your local subarray, and then the global max, which is from the entire array, what is the largest product you can get. And yeah, so let me add some comments real quick. So the max local is, we go edit the comments, right? So the max local is just the current, from the current subarray, max product, and then minimum product, and then just the largest we've seen so far. So the value, mostly the values we're gonna mess with are these, and then all we're gonna do is check if it beats our global max, and if it does, we're gonna reset it, and if not, we're good. This is all assuming that see nums empty, or it is empty. Cool. So we're gonna assume that nums is not empty, and yeah, we'll just go from there. So let me just go ahead and start typing it out. For this one, we're still gonna go through a for loop. We're going to for loop through the list, and we're going to be checking for the values we need. So let's type that out with the for integer iterator is less equals 0, iterator is less than the nums.length, and we'll do plus iterator. Okay, so before we actually start calculating values, we need to check if the current value we are at is a negative, and if it is, we need to do swaps, and if not, then we should be fine. So to make it more readable, I'm gonna create a new integer, current value, right? And we'll just make that equal to nums iterator. So in every loop, the current value you have will be defined here, which is just the value at this iterator position inside the array. Okay, so now we're going to check if the current value is negative. So if current value is less than 0, we need to go ahead and swap the values. So we'll create a placeholder. So placeholder, and we'll set that equal to the max local. And then what we're going to do here is we're going to do max local is now equal to the minimum local, and we're also going to make minimum local equal to placeholder. Okay, so these values are now swapped. So now what we're going to do is we need to go ahead and hold up. So over here, if current is 0, current is negative, swap values. Okay, so now we just go ahead and choose the best value at this position, this point, this index. So what we're going to do here is we are going to go ahead and reset the max local and minimum local. Okay, let's start with the first one. It's going to be max local. So max local is going to be equal to, and as before, we do math.max because we're going to pass in 2 values and it'll return the maximum from those. So we're going to pass in the current value, and we're also going to pass in the max local times the current value. Essentially, all we're doing here is saying if we multiply the current value, the current subarray we have, is it bigger than just current value? And next we do minimum, and for minimum it'll be really similar, but instead of math.max we do math.min because we want the lowest value. So again, current value and then current value times minimum local. Cool. And let's just set that up, and then all we need to do now is update if global max is b. So here we have global max will be equal to math.max, and we pass in here itself, and we're also going to pass in here max local, and this should be all set now. Let's just walk through it one more time. So we initialize all these values to the first index, and then we're going to go ahead and iterate through that for loop. And then we're going to iterate through that array. So we have the current value, right, for readability. And if the current value is negative, we go ahead and swap the values here, right? And if not, we just continue as normal. So we have the local max, and we're going to have that set equal to either the current value we have right now, because that means this beats the subarray we currently have, or we're going to check if we multiply that max with our current subarray, if that beats out the current max. Basically all we're doing is, hey, if we multiply this with the numbers we already have, is that bigger than that number by itself? One scenario where that makes sense is, let's say the current value is 5 and the max local is like -1, right? So this would be 5 and -5, where the current value beats out -1. So that means that the max value would be equal to 5, because within the values we've seen so far, 5 will be larger than any of the other subarrays we've currently seen. But yeah, let's go ahead and paste that in LeetCode and see what we get. Okay, cool. Sorry, I got that wrong. And then I went through my code, I realized what I did wrong, and I forgot that we're actually starting at 1, not 0. My mistake. You know, kind of when you write a lot of for loops, usually start at 0. Here it's muscle memory, hit 0. But yeah, let's run it. Okay, so now we're back in LeetCode, and here's the max product. Here's the code we wrote, and let's go ahead and write it to make sure it works, and then we're gonna go ahead and submit it. Okay, and then submit. Cool. 2 milliseconds beats 62% of Java users. This is okay. But yeah, that should be it for today. Any comments or concerns, leave it down below. Yeah, sorry, this one, the other one. I really don't like these problems.